Good day everyone. Today we are going to learn the different theorems on chords. So the objective for today is we're going to state and apply the theorems on chords of a circle. So we have here a circle and let's define a chord. What is a chord? Let's have a brief view. A chord is a line segment that connects any points on the circle. So this red or line segment in red is a chord because it connects 2 points on the circle. So let's have activity number 1. Supposedly we are going to draw a chord on circle W. So this is circle W and this is the chord line segment SP. Second, draw line segment WK such that point K lies on line segment SP and WK is perpendicular to SP. So this is K, W or WK. When we say perpendicular, two lines are perpendicular and it forms a 90-degree angle. So this here, WK and SW is are perpendicular to each other. That forms 90 degrees. Measure and compare line segment SK and line segment KB. So if you're going to measure the two line segments, what do you think? Yes, they are equal. So what you have done and observed illustrates the first theorem on chords. What is stated in the first theorem? So in the first theorem, the perpendicular segment, which is WK, drawn from the center of the circle to a chord which is SB, bisects the chord. When we say bisects the chord, it is divided into two equal parts. So SK is equal to KB. Let's have the activity 2 and let's determine the second theorem. Supposedly, we are going to draw two chords in circle M such that the distances from the point M to both of the chords are equal. Call the chords line segment AB and line segment CD. So we have here circle M and the chords AB and CD. So measure and compare line segment AB and CD. So if you're going to measure the line segment AB or the chords AB and CD, what do you observe? So what you have done and observed illustrates the second theorem on chords. What do you think is stated in the second theorem? So theorem number 2 or the second theorem, in the same circle or in congruent circles. When we say congruent circles, they have the same radius, they have the same diameter. Yeah, that's congruent circles. Chords equidistant, when we say equidistant, equal distant from the center are congruent. So when we say if AB is equal to 10 centimeter, CD is also 10 centimeter because they are congruent or equal. Okay, let's proceed to example number 1. Determine whether its conclusion is true or false. State a theorem that justifies your answer. Supposedly, this is the figure, circle P. So, first, if line segment PN is perpendicular to line segment CD, then CN is congruent to ND. That is true because according to theorem number 1. Again, theorem number 1, the perpendicular segment drawn from the center of a circle to a chord bisects the chord. So they are CN and ND are equal. So how about letter B? If PM, or line segment PM is congruent to PN, PM is perpendicular to AB, and PN is perpendicular to CD, then AB is congruent to CD. That is true according to the second theorem. The second theorem states that in the same circle, chords equidistant from the center are congruent. How about letter C? If PM perpendicular to AB and PN is perpendicular to CD and PM is congruent to PN, then CN is congruent to MB. Is that true or false? Yes, it is still true according to the second theorem and the first theorem. Let's have example number 2 here. A chord 16 cm long is 15 cm from the center of a circle. So we have here a chord which is AB, which is 16 cm, and it is 15 cm away from the center of the circle, which is C. So CD here is 15 cm long. So how long is the radius of the circle? So the question here is BC. So as you can see here, let's try to get the figure. So it forms a right triangle. Alright, so DC is 15 cm, and the question here is we don't have the radius, which is BC, and DB is equal to 8 cm. Why? Because in theorem number 1, the perpendicular segment drawn from center of a circle to a chord bisects the chord. So AB is 16, so therefore DB is 8. So how do we solve for the radius of the circle, which is BC? So applying the Pythagorean theorem, when you were in grade 9, you had this one. So the formula is C equals A square root of A squared plus B squared. Why C? Because BC here is the hypotenuse of the right triangle. So when we get BC, it is the square root of the two legs, the sum of the square of the two legs, which is A square plus B square. So supposedly our A is 8. Let's just substitute the formula, and B is 15. So what is 8 squared? That is 64 plus 15 squared, that is 225. Add 64 plus 225 and 225, that is equal to 289. What is the square root of 289? That is equal to 17. So we can say that BC, or the radius of the circle, is equal to 17 centimeter. How about let's try example number 3. A diameter and a chord of a circle have a common endpoint. If the length of the diameter is 40 and the length of the chord is 24, how far is the chord from the center of the circle? So we have here a diameter here from Y passes through point Z, that is equal to 40 units, and a chord which is XY, which is equal to 24. The question is, how far is the chord from the center of the circle? So that is, let's take that figure out here. WZ is, we are going to solve how far is the chord from the center of the circle. WY is half of 24, because according to theorem number 1, right? So 24, half of 24 is 12. And YZ is what part of the circle? That's a radius, which is equal to 20, because the diameter is 40 units, right? So the radius is 20. So in here, it also forms a right triangle where one of the legs is unknown. So calling back the formula of Pythagorean theorem, when one of the legs is unknown, so A is equal to the square of the hypotenuse, the square of the hypotenuse minus the square of the other leg of the that right triangle. So A equals square root of C squared minus B squared. So substitute, C is equal to 20 minus B is equal to 12. So what is 20 squared? That is 400 squared minus 12 squared, that is 144. So 400 minus 144, that is equal to 256. What is the square root of 256? That is equal to 16. Therefore, how far is the chord from the center of the circle? WZ, or the chord, is 16 units away from the center of the circle. Let's have this example number 4. A chord 18 cm long is perpendicular to the radius of a circle. The distance from the intersection of the chord and the radius of the outer end of the radius is 3 cm. Find the length of the radius. Here, we have the chord FG, which is 18 cm. We have the radius HI, and it is divided into HJ and JI. HJ is 3 cm. But we don't know what is JI because it is not given. So the question is, how long is the radius of the circle, which is HI? If we're going to take that out, we have here JG is 9 cm. Why 9 cm? Because FG, which is 18 cm, half of 18 is 9 according to theorem number 1. JI, we don't know, so we have to let it as X. So JI is X. Now here, GI, what is GI? GI is X plus 3. That becomes the radius of the circle, right? Because we have HJ, which is 3, and JI, which is X. So if we're going to add that 2, we have X plus 3. That becomes the radius, right? So in this given figure, it forms then a right triangle. And let's solve it using Pythagorean theorem. So the Pythagorean theorem is C squared equals A squared plus B squared, right? C is the hypotenuse, A and B are the legs of the triangle. Now let's substitute. C here is the hypotenuse, which is X plus 3 squared, equals X here is A plus 9 here is B. You can interchange the two, A and B. It could be A, 9, it could be X, which is B. Okay, so let's simplify. X plus 3 squared, that is X squared plus 6X plus 9, equals X squared plus 9 squared is 81. After that, combine like terms. So transpose X squared to the other side. So X squared minus X squared, that becomes 0. 6X plus 9 equals 81. So X squared minus X squared is 0. So what is left is 6X plus 9 equals 81. Since our goal is to find X, so we will transpose positive 9 to the other side of the equation. That is 81 minus 9. So what is 81 minus 9? That is 72. So 6x equals 72. So to find x, divide by both sides by 6. So x is equal to 12. By 12, 72 divided by 6, that is 12. So x is equal to 12. That is only ji. So what is then now the radius of the circle, which is gi? So that is 12 plus 3 is equal to 15 centimeter. That is now the length of the radius. So in this lesson, you were able to learn some values. So we have here chords are congruent if and only if they are equidistant from the center of the circle. So people have equal rights, but they differ in their religious beliefs. How do you show respect for differences in the religion? Thank you so much for listening, and I hope you have learned something today.